Cool. So why do we want to optimize in the first place? The first big takeaway is cost, obviously. So that can be as simple as the resources that we're setting aside for our applications cost money. And if we're having inefficient applications running in production, we're paying for at times more resources than we actually need. So that obviously costs something. But if a performance bug does make its way into production in a way that disrupts user experience or causes a part of our chain of microservices to go down, fixing that problem obviously costs a lot more in production than it does in some isolated staging or development environment. But another reason is that we as an industry contribute maybe more than we think to the carbon output that goes into the environment. We have a real non-trivial impact on the environment like so many other industries. I've linked a screenshot of an article that came out in 2018 that says that by 2040, our industry alone will contribute about half of the current output of the whole transportation industry. And it makes, hopefully you consider that aside from just the cost of the resources that we're using and what that places on our own organizations, but that each of our organizations can take some responsibility of understanding if we are not just paying for, but deploying all these additional resources, we are really contributing to this trajectory that we're on as an industry and this contribution to environmental impact. And so it becomes a role of each of us to optimize purely for the fact of trying to decrease this contribution going forward into the future. But this is a difficult thing to do, right? Many of the applications that we work on have history that we may not have been involved in. They have owners and thousands of commits and ongoing work that it can be difficult to figure out, where do I even start to dig into where there may be performance issues? And even if I find one, where do I start introducing fixes when there are all these other parallel streams of work going on currently on these legacy code bases? So when I sort of frame the problem this way, the two things that it seems to me, at least, that we would need in order to develop a long-term performance optimization strategy as a part of everything else that we're doing inside of our organizations, we're really trying to solve these two things of, can we detect and fix issues reliably and quickly in production? And then how do we make sure that that information, if it is helpful enough to dig down into the real source of that bottleneck, how do we introduce some guardrails, some tests, really, to ensure that when we've dedicated time and energy into fixing those performance issues, that we can feel confident that no regressions will occur. We won't accidentally reintroduce those performance problems in the future in 100 features from now, once we put that time in. So this is an attempt to do a different kind of table of contents for a slide, and it's a lot. So I'm going to try and go for it step by step, but we'll see how it works for us. So these are the two workflows of the companies that are involved here at Platform.sh. On the left side is a tool that I'm mostly going to be talking about called Blackfire. And Blackfire has three components to it that I'm going to go through in this talk. It has, at the bottom, starting at 1, an application performance monitoring solution that can give us information about what's going wrong in production by notifying us when something goes wrong and letting us know that we should drill down and investigate further. We can move on then to number 2, which is profiling, which is, okay, we've gotten a notification that, let's say, our response time on the home page has been degrading over the last 2 months, or 50% of requests that were previously at 200s are now at 404s. we can find that information, take it over into a profiling stage, and dig down deep into figuring out transaction by transaction, each function call, what is it that's occurring here that needs our attention. And then before finishing this workflow cycle on the Blackfire side, jumping over to the right for Platform.sh. If you don't know anything about us, we're a platform as a service provider. Really, the goal here in including platform at all in this talk is just in introducing the fact that the problem we're trying to solve is removing this packaging, provisioning, and deploying stages of your workflows by building that into the Git protocol, essentially. So you create a branch that results in an exact copy of production in a new environment that gets integrated to a GitHub or GitLab repository. And if we can take the notifications we get from our monitoring and set aside a new environment easily with something like Platform to investigate it and profile it, that we can get a more seamless cycle of using those notifications to introduce performance fixes. And the way Platform.sh works becomes a little bit more relevant in terms of the problem I said previously of there's a lot of parallel work going on. How do we ensure that we get environments set aside for people to specifically address performance issues? And so finally, once we have that, I'll introduce the third component of Blackfire, which is how we take performance fixes that we work on and turn them into performance tests so that we can get the beginning of a measure of a performance budget that we want to maintain across the introduction of new features. So if somebody happens to be working on something new, but they violate a test that we've defined in a prior performance sprint, then we'll block that merge from happening and it won't get promoted to production until that performance regression has been addressed. So let's start with monitoring. Here, the idea is that the application performance monitoring part of Blackfire is set up to let us know when something is going wrong in our code. It can give us a breakdown of response statuses that happen on real user traffic, what the lengths of those requests have been, and how that response time is changing over time. And you can think of that sort of in a map of Paris, for example. We're a Paris-based company, in taking a look at all of the outlying regions of Paris and taking some measure of what traffic looks like at the city scale. And it can be combined with some extended traces that are applied periodically to then say, okay, at certain junctions, where are we really getting jammed up that requires us to dig down even deeper to figure out what might be going on. And before moving on to profiling, I'm going to take you to that dashboard. This is a website that you can view yourself if you'd like after the conference. It's called demo.blackfire.io. In this case, it is a Symfony application, not a Python application, but I'm showing it now because it's one of our better examples and the concepts are really exactly the same for this stage. This is our health report for what's being monitored on our production application. It lets us know that response times hovering around 439 milliseconds. We're getting, almost 2 million requests. It also gives us some information about recommendations. In this case, our production app has features that should be disabled in production, but they currently aren't. And so if we get into a better continuous workflow of addressing performance, this really provides a list of kind of quick performance wins that could be introduced as somebody is onboarding or whatever the case. You take on a new application and you want to incrementally improve performance. That's sort of what gets provided in this recommendations. And these are, in this case, specific to PHP, but Blackfire comes with built-in recommendations for frameworks like Django and Fast API and for Python in general that you would see at this same panel right here and begin to direct attention to. What really becomes powerful is this next panel here, which will tell you things like you have transactions that are gradually having more of an impact to the overall performance and overall response time of your website. So if we look at this section right here, I have two transactions that are happening here. Some controllers that are, in this case, in the demo app that I'll show, is providing a list of Bigfoot sightings. And so every time we call this show sighting method, in the last few months, it has increased almost 10% more contribution to the overall response time of our website. Same goes for getting information about the GitHub organization attached to this community. It's even more so. It's having 183% contribution to the average response time of this given page. And so right away, this right here we're looking at is our health report that we're going to get every week or every day, depending on how we set it up. And I can say now, okay, this is a growing problem that indicates something is wrong, and we should really direct attention because this is where our resources are being eaten up. The same goes for calls to the database. We'll get some measures of, in this case, not much contribution to response time, but certainly to the length of requests and the types of request statuses that we're getting, and then this overall impact score that's distributed across things like response time and memory and CPU usage. And from here, I can take that information and look at sort of the live data of what's being monitored in production. So these are real user requests that are being placed on this demo application. And it'll be the same as the one I'm going to show in a second, just like I said, written in Symfony. And so from here, I could say, all right, I want to look at, in this case, requests that are coming from users, and I just want to focus on GET requests, and it looks like they're all 200s, and I have, you know, a good proportion of them, 2,500 of these requests that are taking almost a half of a second or more. And so I can drill down on that response time, see what that response time looks like on the window. I can extend the window, let's say, to the last 24 hours. Let's make sure it preserved my filters there. Yep. And same thing, similar to what we saw on the health report. It's really methods like these that are contributing the most to this overall impact score and to response time, and really are in need of us to address them. And I can take all this information and go, okay, I think I need to dig down deeper and see what's going on with this citing information that I can direct a member of my team to start investigating. If I go back to my slides, that really gets us to the second part of the Blackfire workflow, which is this profiling element. And in this case, what this is going to be able to do is take this when information that we're seeing over time, and it's going to get us down into the why. So we can narrow down on individual transactions and see which ones are the problematic ones so that we can actually know what we're looking for in our code base to fix some of these performance issues. And if we stick with the loose city metaphor I have throughout here, this gives us a detailed picture of the road itself. So we may, from the large scale, see that there's slowed traffic in and around the city of Paris. But with the profile, we can then narrow down and see, okay, that this is due to a road closure at this particular off-ramp inside the city. And so what I will do is I will go to, in this case, I will get to the platform part of this in a minute. But this is what my demo application looks like. It's the same application that gets fed into this monitoring dashboard, but this one is in fact written in Django. And I can show you a copy of what that looks like now. It is just a single application. And what it will do is it'll provide a list of, in this case, dummy content. But the idea is that people can come in and log in and leave a particular sighting report of where they saw Bigfoot in the world, and people can come in and respond to how valid or what it is they think about that sighting. And so it's a fairly simple application, but we got that information that over time we have a longer response time in the last few months. So what I have set up inside my Platform.sh environment where this is running for my production site is two pieces, an agent and a probe. So in that case, I have something that's installed inside of the application container that's capable of sending information to the Blackfire API. And then the probe, which is just a Python dependency that if I don't want to, I don't have to make a part of my code base at all. If I take a look at how this application is actually started on Platform.sh, it really just means including Blackfire Python instead of the regular Python executable in front of our start command. And from there, we'll be able to follow every request that's placed on this app and send it through the agent to the Blackfire side to do things like generate that monitoring dashboard and allow us to take a profile of this page. So let's go ahead and do that. I have an extension installed here inside my browser. And what it's going to do is it's going to use that agent and probe to profile my production application in this case. Okay, so I see generally where the response time is settled. I'm getting some idea of I/O, of CPU usage and memory usage on this page. So what I want to do is move to that specific profile. And we're going to get a pretty informative panel of information about what it is that happened from the start to the end of that request inside this application. Before we move on to this interesting figure here, which is the Blackfire call graph, I want to direct your attention here, which is a list of every single function that ran during that request inside my application. And I can begin grouping that by the length of time it took to go through that transaction, either just by itself or as it was related to other functions that were called, which is not a very informative panel there. But then lastly, I can structure it by the number of calls to that function that took place. So I actually have quite a few here that are in the high thousands. Looks like the get attribute was called quite a few times. If I take a look at where that's called from, we have some Django utils that were actually responsible for calling that function, and another get attribute that was then called by the parent function. All right, let's go ahead and close that. How about this set attribute function? Let's see, it was called, well, this looks like what we found out inside that monitoring portion of our information, which was that this sightings model is calling set attribute 2,500 times in the execution of the request. And that seems like a lot if we were trying to optimize our application here. So we may need to investigate what's going on here. If I go and zoom in on that call, I can see that it has a place here in what we call the critical path of this application's performance, which is something that Blackfire builds on top of this map of transactions that took place. And for anything that falls above a significant threshold, we can see that this was really the chain of function calls that took place that are contributing most to the metrics that we have on top here: response time, I/O, CPU, and memory. And if we keep following that down to the end of the call, we end up at that function that we were just looking at here. We're calling the model database, and we see that there's something going on when we get into this citing call that is giving us issues here. So if I go ahead and move over to my application, let's see what happens here. If I go to my sightings templates, sorry, navigating my code here. I see that there's a few improvements that I can make here to my code where things are being called here a little too much here. Well, I noticed that my comment count, I don't have anything set up for caching on this call. So some of the edits that I've included here are importing the core cache from Django and redefining a cache key to follow up on this comment count call that's happening on every single page. If I go to some of these other parts, I'm not really leveraging this. Let's see. Here we go. Here's a real issue. I'm going through a loop of every single comment every time I'm going on a page before displaying the count of comments that are available. That seems not ideal. So what I'm going to do instead is I'm going to rewrite that function with a filter on a comment class so that it can give me a better idea of that count without having to iterate through all of them. That looks good. And a few other little edits that I can notice here that say, you know, I'm trying to take a length measurement when I really could call this attribute of the comment count. Let's see here. This is the cache that I just enabled. And I have a few other calls here that I can improve. And if I'm curious, if I go into my settings file, yeah, I really don't have any cache defined for this application. So I'm going to go ahead and include that. And so I can make these incremental changes just by taking information from this profile. And every time I make an improvement, I can reprofile and see if I'm going in the correct direction, is really the idea here. But then what do I do with that? I've made some fixes. How do I introduce it into the normal pipeline? So this is, if we go back to this funny table of contents here, how we get into the Platform.sh part of it. And so, like I said in the introduction, how Platform fits in here is that we take what's already built into Git and we use that as our primary model for generating environments. That's not atypical at all. For every pull request that you open, every branch that you create, you could create a new environment for this Python application. Where we differ from some other solutions here is that we have a pretty simple abstraction for infrastructure that I'll show you in just a moment. And because we take care of these three main stages here for packaging your code and provisioning infrastructure, we can build into that some logic about how it is that we handle build images. So as an example, here, I'll go full screen for a minute. As an example, this is a condensed version of the Django configuration I had shown before. Here I have a name for the application container this Django app is going to run on. It's going to need Python 3.9. This is one first part where we kind of make this configuration a little simpler. You don't have to include a minor or a patch version for this Python container. We kind of take care of that in the background, and when a new patch release comes out, we apply it to your environments in the background between deployments. So we don't need to include that. I have a build phase that's going to, in this case, leverage pip and install from my requirements file, and it's going to collect static assets and perform my migrations at deploy time. I can then build out a cluster of these containers defined for a production environment by saying, my code depends on having a Postgres database. And so I want to be able to access that within this cluster of containers, in this case, through the address database. And I should have a slide here. This has a very similar level of abstraction as the Python app contains, which is I don't even need to include a minor version for Postgres. I just include the major version. And anytime any of these upgrades happen or patch releases occur, they just get applied to your project in the background, like I had said. And this is the case for Postgres, but it's the same for a long list of other services. But Postgres is relevant for our Django application here. And so I take those pieces and define a start command and can then build out this cluster of containers that define my production environment by adding a few configuration files to the repo. One for my app config, one for what services I depend on, and then one that just says, how do I want requests to be handled when it gets to this Django application, and push it to Platform.sh. And that is actually what I was showing here. So in this case, I have a project that has two environments, but here is the production environment I was showing you before. And if I click on that project, which is this website here, it has that cluster of containers, Python, Postgres, and then that router container handling requests. And so from there, we can do some interesting things because Platform's going to handle the infrastructure part and how it's provisioned and include some of this configuration, and it's all built into Git. So we can do things like create a new branch to easily upgrade a piece of infrastructure. I had shown Python 3.9 before. What I can do is create a new branch and edit that one line to upgrade to Python 3.10. And I bring this up only because there are marked performance improvements that can be made by upgrading to the latest version of a language. I know one of the recent figures that I saw was upgrading from PHP 7.4 to PHP 8.0 was a 30% performance improvement in terms of memory usage. And at that time, 7.4 had a vast popularity. I mean, it was in usage all over the internet and in popular websites and most of the websites that were using PHP. And so by just providing some simplified path for upgrading that piece of infrastructure, there's a marked performance improvement included just in being able to do that easily. But what happens when we make that change? So before we're pushing the new piece of infrastructure, we're just going to create the branch. And so what's going to get built into Platform when you do that branch command is it's actually going to detect that from production to this new branch, there's been no new commits pushed. So our tree hash is going to be identical for this single application from one environment to the next. And so it's going to recognize that and say, well, I already have a build image put together, the one we have in production, for this unique hash. So I'm just going to reuse it in the creation of this new environment. And as it does that, it's going to pull that build image over. It's going to run through the deploy hooks and the start commands in this new environment, but it's also going to inherit automatically all that data that we had in production into this new environment. And so it makes it easy to make this new commit and push it up to Platform or to GitHub of the new piece of infrastructure and test it in this isolated environment with a new, say, deployfriday.com was our primary URL, our production URL. We can now have, as a part of our pipeline, a new environment that is a true staging server for any pull request that we create. Actually, before I talk about this, I'm going to move back to my project. So what I've done here is I've set up that integration. So I have a repo that is connected to this project, and I've actually opened a pull request that will go through to talk about some of those performance fixes and how they got applied. And in this case, I have an environment deployed for that pull request that we can see here on the project. and we can compare. Here is my pull request environment with data from Postgres, and here is my production environment. And they are identical applications between those two environments. So I can really get a good picture of, if I apply these performance fixes into this new isolated space, is it going to break production? Is it really going to markedly improve production performance? And we can get a pretty good level of confidence because they're identical applications. And that, on top of that, everything that I spoke about, reusable builds, works in the opposite direction as well. So we have this isolated space for this pull request, where we're going to have a true staging environment set aside, where we're going to test these performance fixes. And when we're done and it's gone through every test and every approval from every stakeholder that has to sign off on some new feature or these performance tests, we can go ahead and merge it into production just through GitHub. And when we do that, the same thing is going to happen in that direction as did in branch. So in this case, it's going to detect on production that there's been no, that I already have a build image set aside for the current state of production, which was what we had in the isolated environment. So I can reuse that build image in production. And so this makes a good workflow, not just for promoting these fixes, but also for ensuring that I don't necessarily have to get in line in a dev stage prod workflow for quickly addressing these performance fixes. I can just create a new branch, I can create a new pull request at any point, run my tests, merge into production, and then any subsequent child environments that are in progress for new features can then resync and rebase from those changes if it's relevant to what they're working on. This just slides just to say that none of this is specific to Python. It goes across any of these languages. So improving performance for a decoupled application with React or Vue in front of your Django site would work identically to this situation. But I have a pull request opened that has its own environment now. And I've made the fixes that I was sort of just going through here in an environment deployed. And here is that new environment where I have, let's go ahead and name this. This is my prod profile. It's my prod profile. And I actually want to then see if that really made a difference on this pull request environment. So I'm going to profile that one as well. All right, and I'm going to name it. So this is my performance fixes. And let's go ahead and look at that call graph. All right, so we've helped IO, and we've helped CPU a little bit. I don't know if I can really tell right off the hand if we've made any real improvements here. So what I want to do actually is if I go to my list of profiles, I actually want to compare the two profiles I just took. So you see, I haven't really improved much of anything. I've actually made things worse, which is good because now I know that I was going in the wrong direction and I actually increased response time and increased CPU and memory usage. So in this case, what I would need to do is see, but I did reduce the number of calls. No, I increased the number of calls. So there's still some more investigation that I could go tap the person on the shoulder that put together this sightings function call to see what it is that can still be improved. But at least now I have something to measure because I can't really optimize anything unless I've been able to measure it. All right. So I can move that forward to the next stage of try to bring in somebody else on my team give them the URL to my PR environment and to the comparison of those profiles. And then together we can pair up to try and improve the fixes to actually address what's going on in production. Let's see here. So that's the tools that monitoring and profiling and platform together give us, is that, we can take some information from production, we can channel it then into being able to profile and compare what's going on in production with some work as we're trying to investigate and improve performance. And then hopefully if you have more knowledge of the code base than I do, you can actually improve where it is those calls to the database are really influencing response time, set them aside in a dedicated environment. And like I said, have sort of performance sprints dedicated to addressing this particular issue and promote them to production. But after we've done all that work, the second, or I guess the first problem I said was, how do we prevent any of the work that we've done in improving performance of the application being negated in any way, and reintroducing some performance bottlenecks after we've done all that work. And so that's where Blackfire testing comes into hand. I only have a few minutes, so I'm going to try to go through it quickly. So what we do here is we write a file. It's a Blackfire YAML file that gets committed to the repository. So now every time that we profile the application, we'll actually be able to get some insights into, say, we want to set a standard, as I said, a part of our performance budget, that the response time of our homepage should really never fall above or go above 250 milliseconds. Or we want to limit the amount of memory usage on production site, or any of the SQL queries that occur. We can do that with this file, and then every profile that we take from then on out is actually going to run these tests and provide us that pass-fail signal that we need to give us some feedback on how things are going. And we can hook that up into our pipeline so that it then becomes a check that can't be passed in merging something into production from then on out if there is a failure. I think, yeah. So I'm going to show you a little bit of how that looks like. If I went into any of these individual profiles, we'll see we have a red X here. And that's because I've already included this Blackfire YAML inside my repository. And so in this case, I want to introduce some tests, like I said, of limiting the response time. I want to limit the number of entities created and the queries to the database that occur. And I want this to be done on the home page, and I want to take a follow-up request to the first sightings page that was on that home page of the list of Bigfoot sightings. And really, as the things that I'm trying to investigate that I showed inside the demo, which were, okay, if I'm counting comments and I'm getting some recent comments of an individual user, I'm going to need to get in here and define a custom metric to be able to pull out that information when it happens, when that transaction goes down. So in this case, I'm going to define the callee for that get recent commit count method. And the same goes for the resolve expression inside one of the Django models that we set up for counting those comments. And so with those in tow, I can ensure that, let's say, what did I define them as? User activity calculation and comment count calculation. I could write 2 more tests that'll run on every single pull request related to those fixes that I was just trying to address. So in this case, I want to make sure that they both are within a certain limit. In this case, when we're on an individual sighting page, that the activity count stays at 0 and that the comment count is greater than 0. And I can do something similar for any new method that I make any performance changes on. And so with that, I can look at that failing test here. And they come up as this assertions panel, which in this case, I'm still failing at this response time of the home page, and I'm still making too many queries to the database. And so in this case, I wouldn't merge this pull request, and it would be up to our team to try and figure out how to get this number down by digging into the code with this full cycle of profiling, rewriting code, and profiling again to make sure that we can get either below these limits or into some more reasonable limits for the performance budget that's realistic. And like I said, I can attach this to a pull request. In this case, here is the same demo app that in this case is for another PHP application for Drupal. And here I have the Platform.sh environment deployed. And when that environment deployed, that profile and set of assertions, that build, happened automatically too, and gave me a pass-fail piece of feedback on that pull request. It should be this one. Yeah, so in here, it's going to say that I did fall below the right response time. I did have all my development settings turned off on the home page, and I was able to go to, in this case, a few other paths for known articles that were on that, and the same tests were able to pass as well. So, yeah, I'm gonna go ahead and stop there. So to close out, Blackfire is a really interesting tool for, especially in the reality of teams where people are onboarding and offboarding on larger applications all the time, to give them some ability to investigate what is the root cause, the root bottleneck of along some of these dimensions of memory usage, response time, CPU usage in our production apps. And potentially with something like Platform, but there's not really any reason that you would need to use us specifically. Taking that information to set aside those dev environments to address them directly and tie in performance testing to give a whole organization a real notion of a performance budget that could be enforced in every new feature introduction, and that could then, since it's measured, be optimized over time. And that's great for cost, obviously, but I hope you all can take away that our industry does have some marked effect on the total carbon output that is going into the environment. And with continuous optimization strategy like this with Blackfire, a possibility exists for us to make our own efforts to reducing that over time. I really thank you for joining me for my talk, and I hope you enjoy the rest of the conference. And if you want any more information, you can go to the Blackfire documentation for Python or to our docs for Platform.sh. I'll be sure to share those links in Slack. And yeah, thank you again. I'm here for questions if you have them.